Hello guys. So experimenting with HHO today. It's raining outside, so I went to the beach in Carson Beach in Boston, and I walked down to the water's edge and I got me some seawater, and I took it home here and I replaced my 1 teaspoon of sodium hydroxide and water out. I cleaned it all out with distilled water, and I put seawater in here only, and nothing else, just seawater, and let's see what happens. See if this works. Oh, look at that. Just with seawater, it's producing HHO. Get some bubbles. Seems to be. Look at that reaction right there. Like, it seems to be reacting more now after it's been on for a minute. I mean, look at that increase right there. And look at the water's turning a dark color. This thing's like really reacting. I'm gonna shut it off, guys. And I'm gonna take this over and see if this ignites. Yeah, there we go. It just took a while. Okay, so the salt water, after about a minute, in the beginning it wasn't doing nothing, but you see the color change there? Just seawater. And now it's producing the gas. See if I have any more bubbles in there. I can show you again. See the bubbles there? Just straight seawater. Okay? Shut that off. Bring this over. Take out my lighter. And wow. Oh my God. That's like 10 times more powerful.
That gas can just be fed into your carburetor. And depending on how much pollution controls you have on your car and the age of it, it can be harder or easier to take advantage and get 20, 30%. And if you want to go more serious where you modify the chip in the car for the fuel mixture, you can do different things. But that process of electrolysis requires a lot of electricity to come into the plates, okay? If you were to do that like in your home, like to make gas, it would cost too much, it would draw too much electricity. But because you're in an automobile or a truck and you're producing so much 12 volt, you're wasting 12 volt most of the time when you're in a car, you know. That can be very efficiently utilized by electrolysis. Now, I did a lot of experiments with electrolysis, building things, have a bunch of YouTube things, did a lot with seawater. You know, rather than regular, you see, most people use water and put salt or some type of electrolyte in it to make the water more electric. I was using seawater and had a lot of strange results. But
do you want to tell us? Do you want to tell us what those results are?
Seawater, okay. You see, what I didn't understand a lot of things. I had like explosions and stuff and different things. It's dangerous. But when you get into designing the cell, the operating temperature and the pressure becomes significant. As the cell starts to heat up, it can become more conductive and you can get a thermonuclear reaction. It can keep on feeding on itself and getting, in a sense, better. The reaction's getting better, but the thing that you built it in can't contain it. So sometimes that would happen to me with the seawater. And the seawater would turn to like blue oil, like a gel. You get into like alchemy, you know.
These clouds of tiny bubbles are being produced by energy from the sun, and they may provide a solution to an ongoing challenge with solar energy. If you have been studying photovoltaics, the creation of electricity using solar cells, you are probably aware that we are still trying to find an affordable, reliable way to store the electrical energy created by solar installations. Rechargeable batteries are the storage option that is most often used, particularly for storing energy in off-grid solar systems. But batteries are expensive. They require a surprising amount of maintenance, and they have a relatively short lifespan. To meet this energy storage challenge, research labs around the world are creating new and innovative ways to store energy from the sun. Let's take a look at one potential solution: storing energy using the chemistry of water. You probably know that the chemical formula for water is H2O. This means that a water molecule is made of 2 hydrogen atoms bound to 1 oxygen atom. Interestingly, you can break a water molecule into hydrogen and oxygen using electricity. This process is called electrolysis. To start the process, pure water requires the addition of an electrolyte. When you insert the positive and negative connections from a battery or solar cell into the solution, electricity starts to flow, breaking the water molecules into hydrogen and oxygen. The hydrogen is attracted to the negative terminal. It forms bubbles of hydrogen gas. You can see them forming on this negative wire lead. When the bubbles are large enough, they break free and rise to the surface. Similarly, oxygen is collected at the positive end. Energy is required to break the water molecule apart. Chemists call this an endothermic reaction. It turns out that you can regain the energy that was used in this process by recombining the hydrogen and oxygen atoms. When you do this, energy is released, usually in a flash of light and heat. And surprisingly, a water molecule appears, H2O. Chemists call a reaction that releases energy an exothermic reaction. How much energy can be stored in a hydrogen system? Lots. The 3 main shuttle engines are powered by hydrogen and oxygen. They are contributing over 5 million newtons of thrust to this launch, a dramatic demonstration of the power in hydrogen. Here is a summary of the chemistry behind using water as a solar energy storage system. We start by using energy from the sun to create electricity. Use that electrical energy to break water into hydrogen and oxygen. Store the hydrogen. And then when you need some energy, allow it to recombine with oxygen. Energy is released and water is created. This 5-watt solar panel is an amorphous silicon panel, a type of photovoltaic panel that is durable and efficient. Even though it is a bit overcast today, there is enough light coming through the thin cloud cover, and this panel will produce some current. Back inside, I have the positive and negative leads from the panel suspended in water. We can see bubbles rising from the negative terminal. This is hydrogen. Energy from the sun is separating water molecules into hydrogen and oxygen. To collect some of this hydrogen, we can invert a test tube filled with water over the negative lead. Hydrogen bubbles into the tube. It is not necessary to capture the oxygen, as the atmosphere has adequate oxygen for reacting with hydrogen. Once we have some hydrogen captured, how do we use it? One of the most innovative ways to use hydrogen involves a device called a fuel cell. Similar to a battery, this device creates electricity, but it does this by combining hydrogen and oxygen. Hydrogen is introduced to one side of the cell, and air containing oxygen to the other side of the cell. The hydrogen and oxygen combine, releasing energy that is used to create electricity. And the byproduct of this process is water. There are a number of experimental electric vehicles using this fuel cell technology, including this bus. Hydrogen is the fuel moving this large vehicle. Exciting to think that we can use photovoltaic cells sitting in sunlight to produce hydrogen and use that hydrogen to power vehicles. The carbon footprint from this process is very small. There are problems with handling and using hydrogen. It is very flammable. Never experiment with hydrogen. Leave that to the experts. Another issue with hydrogen is storage. Hydrogen is the smallest atom, making it very difficult to contain. Current containment systems require extreme pressures and temperatures, but researchers are developing some creative ways to use chemistry to store this tiny atom. If you are interested in a career in the energy field, there are lots of opportunities to contribute to the development of safe, renewable energy resources. For more information about solar...
Okay guys, I just wanted to let you all know that the longer that this salt water stays running, the more gas it produces. Salt water has an effect that it's working better than the sodium hydroxide in water, that's for sure. But as you can see, like all the organisms in the salt water just turning dark. I don't know if you can hear it. It just seems to, it sounds more powerful. And the gas is definitely more powerful. What do you think, Jesse?
I think it's more powerful. That second explosion we did, that was...
Yeah, we've been lighting it off for a while, and it's just, the explosions seem a lot louder than usual, so...
Why don't we let them see?
I don't know if there's any more.
Power left?
No, there's definitely...
There's definitely
soap.
power left.
I'm talking about the soap in the bucket. So take that off, and you can go ahead and light that off. Don't need some, just a few bubbles right there. Go ahead, Chris. Whoa. Definitely 10 times more powerful than my ears are ringing.
Mine are too.
That's crazy, guys. The salt water is freaking me out. It's so powerful. The gas is a lot more powerful than with the electrolyte and water. So there's got to be something said for nuclear power plants being near salt water a lot. What if these nuclear power plants are just producing HHO and turning it into electricity and just lying to us just like they do with the planes and everything else? This is real, guys. Salt water is producing HHO gas that is powerful. My ears are still ringing.